This video will have two examples of solving rational equations. A rational equation is one that has x in the denominator. So the first thing we want to do is factor the denominator. So we can see that this first denominator can be factored by pulling out the GCF of 4. And none of the others can be. This is really -1/1 if you'd like to write it like that. And the next thing we need to do whenever we have fractions is get a least common denominator. So we want to look at everything that's in the denominators except 1, since that is not a factor that really counts. So the factors that we have are 4 and x minus 6. So our least common denominator here has to include one of each. So it's going to be 4x minus 6 because we can make all the denominators look like that pretty easily. The first denominator already looks like that. The second denominator we can multiply by 4 times x minus 6 to make it look like that. And the last denominator we'd only need to multiply by 4 since it already has the x minus 6 in it. I rewrote this quickly, spreading it out a little bit more. So again, we said our first denominator is good. The second one we need to make look like 4x minus 6. So it needs to be multiplied by 4x minus 6. And whatever we do to the bottom, we have to do to the top. The last fraction already has the x minus 6 in it, so we do need to multiply by 4 to make it look exactly like the other ones, because it's missing the 4. So we'll multiply by the 4, both top and bottom. All right, so let's rewrite this. Our first fraction does not change. Our second one does. The numerator becomes 4x minus 6, as does the denominator. And the last one becomes -16, since we're multiplying over the same denominator. Once we have the same denominator, we can eliminate it because it's like three things being divided all by the same thing. So we don't really need the denominators anymore once they're the same. So what we have is -3 minus 4 times the quantity x minus 6 equals -16. And from here, it's a fairly simple equation to solve. So we'll first distribute the -4. And we'll combine like terms and solve for x. So over here, we can combine this to a plus 21. Then what we'll do is subtract 21 from both sides. And we'll have -37. And therefore, our final answer when we divide by -4 is positive 37/4. Kind of a weird answer, but it works. We do have to make sure, though, that plugging this back in does not give us a denominator of 0. When we have rational equations, again, that means we started with x in a denominator from the very beginning. Therefore, there could be a possibility that the value that we plug in makes our denominator 0. Well, let's see. What would be the only value if we plugged in here that would make this 0? It would be 6. 4 times 6 is 24, minus 24 would be 0. Same here. So 6 is the only value that we couldn't plug in if we got it for an answer. We did not get the value 6 as an answer, so this is a viable solution. In this next example, we are first going to factor the denominators if we can. These two cannot be factored anymore, but this one can be. Two numbers that multiply to -5 that add to -4 are -5 and +1. All right, now it is factored. Let's take a look at what our LCD is. Our LCD needs to include all the factors in the denominator listed once. So all the different factors are x minus 5 and x plus 1. So our LCD is going to be x minus 5 and x plus 1. So in this first fraction, it only has the x minus 5. We need to multiply it by x plus 1 so it has the entire LCD. For the second fraction, the opposite is true. We need to multiply it by x minus 5, top and bottom. And the last fraction, we don't need to multiply by anything because it already has the least common denominator as its denominator. So rewriting this, we'll do some multiplication. Up here, we can rewrite this as 3x squared plus 3x equals, we'll then distribute the 2. So we'll have 2x minus 10 plus our last numerator, 2x squared plus 40. All the denominators are now the same, therefore we can eliminate those denominators. All right, going on to solve, we'll see if we can combine any like terms on any of the sides. So we'll have 3x squared plus 3x equals, and I'll write this as 2x squared plus 2x, and then we have a plus 30. Let's get this all equal to 0. We can see we have a quadratic. So I'm going to subtract 2x squareds from both sides. I'm trying to get this right side to 0. Then I'm going to subtract 2x from both sides. And then I'm also going to subtract 30, and I don't really have a space to write that, so I'll just subtract 30. So we're left with 1x squared, and we're also left with 1x, and then I needed to subtract the 30, so I'm going to subtract it on this side. So minus 30 equals 0. When you have a quadratic as a final answer, you do need to get it equal to 0 because we are going to have to either factor it, most likely factor it, in order to solve. So this has a lead coefficient of 1. Two numbers that multiply to negative 30 that add to that 1 in the middle, that 1x, are a positive 6 and a negative 5. If you FOILed that out, you would get back to this here. We'd have x squared minus 5x plus 6x minus 30. Then, in order to solve, we set each one to 0. Our solutions end up being, our possible solutions are negative 6 and 5. I say possible because we do have to look back at the very beginning and see what values of x would make our denominator 0. Well, our denominators are all x minus 5 and x plus 1. The values that would make those 0 are 5 and negative 1 if you plug them in. So if we got either 5 or negative 1 as a solution, it would not work. Therefore, that can't work as a final answer. Our only final answer is negative 6.